Okay, let's get started. So we finished the first part of worksheet 3, and it's asking for electric field on the second part. I think you guys can do that. Electric field is just like we did in the this second problem. You find the electric field due to all these three charges at that point, and then add them vectorically. Now for C and D, C is asking how to find what would be the potential energy of an electron at that point. So we found, so we had three charges, and we found the potential energy of these three charges at this point. So we found U, not potential energy, we found V, potential. So then if I place an electron at that point, okay, what would be the electric potential or electric potential energy of the electron at that point? Okay. So to find that, we have this formula. So we defined electric potential as potential energy per unit charge. Okay. If I want to find potential at that point, you just rearrange this formula. So potential energy would be Q times V. Okay. So in this case, it's electron. So electron is 1.6 times 10 to negative 19 Coulomb. Okay, and then potential is whatever potential you find. Okay, that's that. So that gives you the potential energy of this electron due to these three charges. Same thing with the electric field. So you can find the electric field at that point. Okay, you can find E, and again, to find the electric field, you need to find individual electric field due to this one, electric field due to that one, and electric field due to this one at that point. Okay, and once you have electric field, how much force these three charges will exert on this electron. So that would be given by, force is given by, because we have the definition of electric field is force per unit area, sorry, force per unit charge. Okay, so that means we can rearrange that to get F. F is Q naught E. Okay, and with that you find the force. Okay, and the force will have same direction as the electric field. Okay, so direction would be same as electric field. Whereas for potential, so here you want to use this absolute sign because the direction is given by direction of E, but here if it is negative, you want to just use negative here. Okay, so the value you get will be a negative value, so you will have a negative potential. Okay, negative, because we have electron has negative charge, so that negative would be carried to the answer, so that joules. So that's how you get force and potential energy from potential and electric field. Okay, so we saw so far how to find potential energy. Okay, potential energy is energy when you bring a small test charge from some point to some point closer to this charge, source charge, that's the potential energy. Okay, and potential energy, just potential is if you were to place a small test charge here, how much potential energy it will have, potential of a unit charge, that's the potential, electric potential. So we also know how to find potential. Okay, if you know potential energy, you can find potential, and vice versa. If you know potential, you can find potential energy, because we have this relationship, U is Q times V. Okay, that gives us U in terms of V and V in terms of U. And we also know electric field and force. Force is force between any two charges. So if you have two charges, they exert force on each other. Okay, that's the force. And if you place a tiny test charge, then you use the term electric field. So electric field is, if I were to place a positive charge here, small tiny positive charge, how much force it will feel due to that due to that charge. Okay, that's the electric field. So electric field and force are related. Both are vector quantities, so they are related by force is Q times E. Okay. So if you know electric field, you can find force, and if you know force, you can find electric field using this formula. Now somehow we need to also see the connection between these quantities, okay, V and E. So the connection between V and E is electric field is also defined as change in potential over change in distance, over some distance. You can just say distance. Okay. So this formula relates electric field and potential difference. So what that means is, if you have a bunch of positive charges, okay, and let's say some negative charges, or it could also be positive charge, let's just say one positive. So there's more positive here than here, so this one is at higher potential. Okay, whenever you have more positive, it's said to be at higher potential. So let's say this is V2, higher potential, and this is V1. Okay, and electric field always goes from higher potential to lower potential. So there's electric field originating from this positive charge, and it always goes towards the lower potential charge. Okay, so this is electric field, and this electric field comes from the fact that we have this potential. If you have same potential, let's say you have 3 positives here and 3 positives here, then you won't have any electric field here. Okay, no electric field. So in order to get this electric field, you need some difference in the potential. Okay, you need to have an unequal number of charges. It could be either more positive, less positive, or it could also be positives and negatives. Okay, that's also a potential difference. So whenever you have potential difference, this delta V, okay, delta V is V2 minus V1, change in potential, that gives you electric field. So that's what this is. Okay, so electric field depends on potential difference, and it's the ratio of potential difference over the distance between the charges. So that distance is d. Okay, so now we saw all these variables related to each other. So U is related to V, V is related to E is related to F. So if we know one, then we can find the others. So with that relationship, we can get one from the other. So let's use this and solve some problems. Let's see. So here is a problem number 4. Let's see if I can copy this. Okay. So we have this 2 plates that have 2 different charges. One plate has positive charge and other has negative charge. So this kind of charge configuration is called parallel plate capacitor. Okay. So parallel plate capacitor is you have 2 plates with positive on one plate and negative on other plate. Okay, so that's that. So the question tells us that, let's say you place a charge near the negative plate, point P. So you put a charge here, and it starts from that point and it will move towards the positive charge. We know this is negative, so it would be attracted by positive side, positive plate, because unlike charges attract. So this negative charge, so we have this negative charge, it moves towards the positive charge. So we have this electric field. Electric field exerts the force. So this charge is attracted, that means there is some force acting, and the force that acts on this is the electric field. So electric field acts the force in such a way that if it is positive charge, it is pushed by the electric field. That's something you need to remember. If you have a negative charge, it is pulled by electric field. Okay. In other words, positive charge moves in the same direction as electric field. Okay, move along electric field, direction of electric field, and negative charges move against or in direction opposite to an electric field, in opposite direction. So we have a negative charge here, and this negative charge moves against the electric field, okay, in the opposite direction. In other words, you can say the electric field attracts this negative charge, or you can also say these positive charges attract the negative charge. Okay. So let's look at the question. Find the time the particle takes to reach the positive plate. So how much time it takes to reach the positive plate? We need to find time, and we also need to find, just before hitting the positive plate, what would be the speed, so V final. So how do you find V final and time? If you remember from your physics 1, there are 2 ways to find this kind of variables. Okay, whenever it comes velocity, time, acceleration, distance, these things are something that we see in kinematics. So we can use kinematics ideas to solve this problem, or you can also use conservation of energy. Sometimes you can also use conservation of energy. So we'll see both the ways to solve this problem. Let's first see the kinematics. Okay. So if you guys remember, there are 3 formulas in kinematics to deal with this kind of things. The first formula is, if we have final velocity, if we want to find final velocity, we can use this formula, Vi plus At. Okay, that's the first formula. Second formula is, this is just the review from your physics 1. We also use delta x, which is the distance, is equal to Vi t plus 1/2 At squared. And we also have this formula, what's that formula? V final squared is equal to V initial squared plus 2a delta x. Okay, so we need to use these three formulas, or one of these three formulas, to find these things. So which one would be useful in this case? Initial velocity is 0 because it starts from rest, so this thing is, this guy is 0, that thing is 0 because it starts from rest, that is 0. So time is unknown. Okay, that means we cannot use this formula. We don't know time. In this formula, we know the distance between the distance traveled by the charge is 15 centimeters, so that's known. Acceleration is unknown, and Vf is unknown. If we can somehow find acceleration, then we can use this formula. Okay, so we need to know A to find this. Let's look at this one. So this is known. Okay, that's the distance, 15 centimeters. Time is unknown, we don't know the time, and acceleration is unknown. So if we could somehow find acceleration here, then we can find time from this equation, because this is known. Okay, and if we know A, we can find T. That's what we need to find. And in this equation, if we could find A, then we can find V. That means for both equations we need to find A first, acceleration first. How do we find the acceleration? Acceleration is the result of what? Force, right? You produce the acceleration by applying some force. If I apply some force, I produce the acceleration. And what's the formula for force and acceleration? It's Newton's second law, right? Force is equal to mass times acceleration, or acceleration is equal to force times mass. So we can use this formula to find acceleration. Now, what's the force? What force is being applied to electron? Or what is the thing that is pulling the electric field? I mean, what is pulling the charge? I just answered that. It's the electric field that is pulling the charge, right? So the force comes from the electric field, and we know the relationship between E and F. E is force per unit charge. So that means if I want to find force, I just do this, Q times E. Okay, these are all vectors, but I will not write the vector sign here because we just need to find the magnitude. So QE is F, and then that's the mass. So let's find acceleration. Acceleration is Q. Q is in this case given, so negative. Again, it's just the magnitude, so I will not worry about the sign. I will not put the sign here. 1.6 times 10 to minus 19. Electric field is not given. No, it's given. That's the electric field, which is 3000 Newton per Coulomb. And then mass of the electron, or in this case whatever charged particle that is. It doesn't say electron, but just by looking at this we can say it's electron. Electron has that much charge. So mass is 9.1 times 10 to minus 31 kilogram. Okay. So you do that calculation, and then let's do that. Okay. So 1.6. Okay, what did you guys get? Okay, 10 to 14. So that's meters per second. Now we know acceleration, so we can find now Vf. So Vf is square root of 2 times that, 5.3 times 10 to 14 meters per second. Delta x is given 15 centimeters. So 15 times 10 to negative 2 meters. And then you can find that. Where is the square root? Square root. Is that 1.26 times 10 to 1, 2, 3, 4, 5, 6, 7? Is that 7 meters per second? Is that right? So that's the velocity. Okay, so double check that answer, I may be wrong. And then once you have that, you can find time. So time would be from this formula. Time is 2 times delta x over a square root. Two times delta x, 15 times 10 to negative 2, and a is, we just found that, 5.3 times 10 to 14 meters per second. That is in second. Okay. That would be a very small number. What did you guys get? Okay, 2.4 times 10 to negative 8. Okay, it's a small number, so it takes really short time to reach that distance. Electrons travel really fast. Okay, so that's using the kinematics. Now let's also see another problem where I will use energy conservation. Okay, you can use kinematics, but there's another way to do that problem. So let's look at, let's see, number either 5, both are similar kind of problem, 5 and 6. So I will show you maybe 6. Okay, so again we have 2 plates here, positive plate and negative plate. We call the configuration as a capacitor. So that's positive. and that's negative. The potential difference between these two plates is 80 volts. So, delta V is 80 volts, and again the reason there is potential difference is one has more positive and other one has more negative, or you can say also less positive, more positive or less positive, more positive and more positive here and less positive here, or you can also say more positive here and more negative here. Okay, so that's the potential difference. Difference in the charge produces the potential difference. So a particle starts from this point, okay, near the negative plate, and the particle has charge given by that, mass given by that. What's the final speed of this particle when just before hitting the positive plate? So we want to find Vf here. Okay, same kind of problem we did before. So this particle has some total energy at this point, let's call that point 1, and some total energy at point 2, and the energy is conserved between 1 and 2. Okay, so the total energy at 1 is equal to total energy at 2. So the total energy at 1 is potential energy at 1 and kinetic energy at 1 is equal to total energy at 2 is potential energy at 2 plus kinetic energy at 2. Potential energy is denoted by U1 for our charge. Kinetic energy is 1/2 mv final squared, sorry, V1 squared, that is equal to U2 kinetic energy 1/2 mv2 squared. Now at this point in the beginning, just before it starts to move, its speed is 0. Okay, initially it starts at rest, so that means V1 is 0. Whenever it starts at rest, you know from physics 1, anything that starts from rest has initial velocity 0, so this is 0. And we don't have potential energy. Potential energy is not given, but we have potential difference. So you see the difference between U and V, right? And you know how to find one from the other. So U is Q times V. We know that. This is given. This is not given, but we have that in formula. So we can turn that into delta into V by using this formula. So Q times V1 is equal to Q times V2 is equal to 1/2 mv2 squared, and then oops, that's plus, this thing is plus, and then we can take this to this side or this one to the other side, whichever you want to do. So Q V1 minus V2 is equal to 1/2 mv2 squared. Okay, it's just rearranging the things. Now I want to find V2, so I want to write this in terms of V2. So let's rearrange more. So this will give me 2Q V1 minus V2 is equal to, I can bring this m also down here, so m V2 squared. Okay, and we are given this delta V. Delta V is final minus initial. This is given. So I want to write this in terms of final minus initial. So if I do that, I will have to pull negative sign out. So I can write this as V2 minus V1. Okay, so this is minus V1 minus V2. Just by pulling negative sign out, you can reverse the order. That's what I did here. I reversed order by pulling negative sign out, and then I have m here, and I want to get rid of this square because I don't need square, I just need V2. So to get rid of that, I need to put this square root on this side. Okay, again, if I square on both sides, I get the same thing back. So we got everything here. Now we just need to plug in the numbers. So let's plug in the numbers. So V2 is minus 2 charge of the electron is minus 1.6 times 10 to negative 19 Coulomb. V2 minus V1, delta V is given, which is 80 volts. And the mass of the electron is also given, 9.1 times 10 to minus 31 kilogram, and you do the calculation, that will give you the velocity. So what did you get for the answer? Okay, so 5.3 times 10 to 6 meters per second seems like the right number, because electrons usually travel at very, very high speed. So that's the speed of the electron just before hitting the positive plate. Okay, so now you saw both ways to solve this kind of problem. So with that, I think you can do all the problems from worksheet. Okay, let's look at homework 7. You can do number 1 and 2. Did you guys try number 3 from homework? So let me give you a little bit of hint on number 3. Okay, so in number 3 you have two charges suspended by some string. So let's say you have, that's the central line, and you have a charge on this part and charge on this part. They are repelling each other because they have the same charge, same kind of charge. Could be positive or negative and negative. Come on, let's okay, so they are same charges and they are at 30 degrees from each other. So that angle is 30 degrees. That means if this is the bisector middle point, then this would be 15 degrees and this would be 15 degrees. The total angle is 30 degrees. The length of the string is, this L is 0.2 meters. The mass of this particle is 5 times 10 to minus 4 kilogram. And again, they are repelling each other because they are same kind of charge, they have equal charges. So what is the charge on each of the particles? We want to find Q. Okay, so this one has Q and that one also has Q, same charge. So how do we solve this problem? This is a force problem. Okay, so the way to tackle this problem is by looking at what forces are acting on this particle. So can you guys tell me like what forces are acting on this particle? You have done this kind of problem in physics 1. Okay, so a mass hanging with a string, what forces are acting on this object? Suppose you are pulling this way, so what forces are acting? You don't remember from physics 1? This one has mass, that means there must be gravity force. Okay, force of gravity acting down. There is string. Whenever you have a string, you have tension force. Tension force is along the string, so let's call that T. And also this charge is pushing this charge away because they have same amount of charge, or they are same kind of charge. So there is also this repulsion force, which we call electric force. Okay, Fe. So these are the three forces that are acting on this charge. Okay. Now in order to find Q, we have this relationship from Coulomb's law. So Coulomb's law is F is equal to K Q1 Q2 over distance squared. If we could somehow find this force, then that will give us that, because we know the distance between these two charges. If we can find that, distance is something we can find. So to find the charge, we need to first find that. So let's find Fe. Okay, so you can draw a free body diagram with the x and y axis. So that's x axis and that's y axis. So we have positive x and positive y. So we have tension, that's the tension, and we have that force, electric force, and we have Fg down. Okay, so we need to add x components separately and y components separately. That's something we always do when we do the vector addition. So let's make a table. Put all the x forces on this column and all the y forces on this column. So we have this one along x direction. So Fe is x force and it's pointing to the negative x direction. This is negative x, so we need to use minus sign there. Fg is all along the y direction, so Fg is down. Again, it's negative because it's pointing down. Now this one, tension, has both x component and y component because it's in between x and y. So we need to resolve T into x and y. Okay, we need to get Tx and Ty. So to do that, we need this angle to resolve the tension. So what is that angle? That angle is, so we are trying to find this angle, okay, which is this angle, this theta. So this angle is same as that's this angle, vertically opposite angle. Okay, this is it's like you have this angle, what you want to find, and that would be equal to this angle, vertically opposite angles, which is this small angle. See, this is 15 degrees. Okay, this is your string. No, that's not. Oh no, the vertical opposite angle is, let me use, I didn't say it correctly, so I'll take it back. So this one is vertically opposite to this angle. Okay, these two are vertically opposite angle. So if I know this angle, then I know this angle, but we don't have this angle. What we have is this angle 15 degrees, and this whole angle is 90 degrees. So 90, this whole minus this 15 would give you this angle, which is 75 degrees. Okay, so this would be now 75 degrees, because this small angle is 15, so 90 minus 15 is that angle 75. So this is 75 degrees. So our x component of tension would be tension cosine 75 degrees, and it's along positive axis, so it's positive number. And then y component would be t sine 75 degrees. It's also positive because it's above the origin. So that's the forces. Now we know from Newton's second law, the sum of this force, x force, is equal to ma, and sum of y force is also equal to ma, but in y direction. Now there is no acceleration, it's in equilibrium. Okay, this object is not moving up, down, or left, right, so that means there is no acceleration. There is no acceleration along both x and y. That means the sum of x should be equal to 0. So Fe plus t cosine 75 degrees must be equal to 0, and then sum of these two also must be equal to 0. Fg plus t sine 75 degrees would be 0. Okay, so in both equations we do not know t. Okay, t is not given, so we need to eliminate t. So somehow let's eliminate t. So write this in terms of t. So Fe, we can take this to the right side, so Fe would be equal to t cosine 75 degrees, and then we can write this as t is equal to Fe over cosine 75 degrees, just rearranging the things. Now substitute this in this equation. Okay, so minus Fg is equal to Fg plus Fe cosine 75 degrees. Okay, that's the value of, that's t, and we also have sine 75 here, so sine 75 is equal to 0. So we want to find Fe, so write this in terms of Fe. So take this Fg to this side, so Fe, sine over cosine is tan 75 degrees is equal to Fg. Okay, basically I have Fe, and then sine over cosine is tan, and then Fg goes to the right, and then Fe would be Fg over tan 75 degrees, and Fg, force due to gravity, we know is mass times acceleration due to gravity, so this is m times g over tan 75 degrees. Okay, now we need to find the force. Okay, so let's find that. M, mass of the charged particle, what is it? Five times 10 to negative 4. So 5 times 10 to negative 4 kilogram. Okay, g is 9.8 meters per second squared, and then tan 75 degrees. Okay, so let's find that out. 5 times 10 to negative 4 times 9.8, that divided by tan 75, that gives me 1.3 times 10 to negative 3 Newton. Okay, so I got that. Now we need to find charge. So we know that this is from Coulomb's law, K times Q1 Q2, and both the charges are same. So we'll just write Q and distance. So distance between two charges. We have charge here and charge here. So the force is Q1 Q2 times over distance square, this distance. And we don't have this distance given, but what we have is we have this angle 15 degrees and this length, which is point something 0.2 meter. Okay, so that's 0.2 meter. So we have this triangle with this angle 15 degrees, and this is 0.2 meter. So we can find this distance. Okay, so which would be using sine theta. Sine theta would be that distance perpendicular over that 0.2 meter. So that would give me 0.2 times sine 15 degrees, which is 0.2 times sine 15 degrees. That's 5.176 times 10 to negative 2. Now this is just a half distance. Okay, that's just a half distance. Now we want this total distance, full distance. That means the distance here would be 2 times that. Okay, so 2 times this half distance will give us the distance. So that's 5.176 times 10 to negative 2 squared is equal to this force is now that force. Okay, that's the electric force, 1.3 times 10 to negative 3 Newton. And then Q1 QQ is Q squared. Now do the rearrangement here, 1.3 times 10 to negative 3 Newton, and then bring this to the top here, 2 times 5.176 times 10 to negative 2, that's squared. And then on the bottom you bring this K down. So value of K is 9 times 10 to 9 Newton meter squared per Coulomb squared. Okay, and then Q would be, we need to take the square root of that, 1.3 times 10 to minus 3 Newton, 2 times 5.176 times 10 to minus 2 squared over 9 times 10 to 9. Okay, do that calculation. That will give you the value of Q. And we don't know whether it's positive or negative. It's just they are the same kind of charge. It could be negative negative or positive positive. So that gives you the answer. You can do the calculation and tell me the answer. Okay, I think we are out of time. If you guys have answered, tell me an answer. Otherwise, that's all for today. We'll meet after fall break. We have exam coming soon, so did you guys get answer? No? Still working? Okay. So just do the calculation, that will give you the answer.